So in 7.5, we're going to talk about the second moment of area. Second momentum of area. If you go ahead and briefly kind of page through the book, you can see that there are some issues with this. And if you go to like page 219, there's a equation there that has a sign that you have no idea what it is. You have what? I, Z, Z, from R squared dA. Okay, so this is an integration symbol. Integration is what we learn in calculus in the second semester. And nobody's had calculus here. So, I mean, there really is no point in kind of going through this, but what I really want you to understand is just kind of what the second moment of area is, okay? What is it? And if you look at page 217, the second moment of area, also known as the area moment of inertia, is an appropriate property. It is how hard it is to bend something. In other words, how resistant are you to that motion, the bending motion, okay? So obviously this comes into like construction, you know, materials of how to use, what to use, what shape of material to use, these type of things, right? So the example that they give you is on the bottom of page 217. It shows you an I-beam there, okay? First of all, why even make an I-beam, right? Why not make a steel girder that is that's like a square, right? Why not make it a square? Why make it into this shape? Right? Use the same solid material. Why not use it like this? And the reason being is because of the second moment of an area, right? It is the inertia. Because if I just do it this way, it is much more, so this guy here, the plain square beam is much more susceptible to bending, right? It bends easily, whereas an I-beam, okay, whether it's A or B, which one would be harder to bend if I have the force going down, do you think? Which one is more resistant to bending? No guesses? Okay, so it's A. A is more, it's harder to bend A than it is to bend B, okay? Now, so if you go to page 218, it shows you the bending motion, right? Okay, it shows you the bending motion, okay? Now, again, I'm not gonna have you go through the integration process and figuring out how to come up with the equation. Okay, what we wanna know is go flip the page. If you flip the page on 220, let's just go ahead and use the results. So if you have a rectangle, all right, and there's an I, or the moment of inertia for XX and YY. The XX means across the X axis, okay? And the YY means across the Y axis there, okay? So across the X axis, what do you have? You have width times h cubed, the height cubed, right? Divided by 12. Whereas across the y-axis, if you think of the y-axis, right, it is the height and the width really gets just switched, right? Because you're looking at a different axis, okay? So in other words, if I have a rectangle that looks like this, and it has width and it has a height, if I put a force down this way, okay, then I'm looking at, force is across, it is perpendicular to this guy here. So the second moment of area is going to be what? 1/12 WH cubed, right? Because the thickness of this thing, if it's thicker, obviously, okay, that's gonna control more of whether the length, right? Okay, all right. So there's that, and then the circle. If you have a circular rod type of thing, right, then the XX or YY is the same because it's a circle all across either way, and it's pi over 4 r to the 4th. Okay, so just know those three. I mean, those really what all I want you to do is really know how to apply it to an engineering problem. Okay, so there you go. If you go to table 7.8, there's examples of the second moment of area standard beam. So it gives you the beams, all right, and it gives you the IXX and the IYY. Again, you don't even have to calculate this stuff. It's given to you in tables, okay? And also, when you're actually doing a design, if you bring up the I-beam, it's going to show you what it can handle, okay? So, and what I'm saying is that, you know, yes, being able to calculate it is nice and good. Understanding the theory behind it is nice and good, but in the end, it's going to be given to you. Okay. I'm not going to go over the examples. Example 7.4 and 7.5, and nothing more than, again, just nothing more than just plugging and chugging, putting in those putting into the equation we just talked about. Okay. All right. Any questions there? All right. As you can see, these are fairly simple, both